Python Basics for Market Research Analysis. This lesson helps you analyze real customer survey and behavior datasets using Python. Market Research Insights guide product, campaign, and service decisions. You will practice summarizing survey answers, segmenting customers, and finding data-driven insights. We focus on business value, not just code. By the end, you will extract actionable findings from real market data. Running the cell now. We import pandas for handling data tables, which are central to market research. We import numpy for working with numbers and basic analytics functions. We import opaml to easily access real-world survey and campaign datasets. We import warnings to manage output clarity. We use warnings.filter warnings to suppress unnecessary warning messages for cleaner results. Running the cell now. Core concepts in market research data. Surveys capture customer opinions, experiences, or intent. Each row usually represents one response or customer. Columns can be answers, demographic info, or purchase behavior. Ratings, such as a 1 to 10 scale, choices, and open-ended text are common. Beginners often confuse scales, such as interpreting high NPS as bad, or mix up who answered questions. Market analysis looks for patterns that drive business action. Running the cell now. Let us start with real customer satisfaction survey data to see typical fields and structure. We add a comment to clarify our intent. We download the public customer satisfaction dataset from OpenML. We get the actual data as a pandas data frame. We print the number of records and columns to get a sense of dataset size. We preview the first 3 customer records to see how the data is structured. Running the cell now. This output shows the customer satisfaction dataset with 7,043 survey responses and 20 columns capturing demographic info, service usage, and billing details. Notice the mix of categorical columns like gender and payment method, alongside numerical ones like monthly charges and tenure, highlighting the diverse data types common in customer surveys. This setup allows us to explore how different factors relate to customer churn, reinforcing the lesson that each row is one customer and columns represent their attributes or answers. Practice: what business questions could you answer from this customer satisfaction data? Understanding customer demographics is critical for market segmentation. We add a comment to state our business focus. We display how many customers identify with each gender. This helps brands check representation, spot biases, and tailor their approach. Running the cell now. This output shows the count of survey respondents by gender, with slightly more males, 3,555, than females, 3,488. Notice how each row here represents one person, so the value counts reflect the number of responses per category. This helps us understand the sample composition, which is vital for interpreting survey results accurately and ensuring balanced representation. Churn describes customers leaving a company. High churn signals service or product problems. We comment to show our business goal, find churn rate. We calculate the percent of customers marked as yes for churn. We print the churn rate as a clear percentage for managers. Running the cell now. This output shows that 26.54% of the surveyed customers have churned, meaning they stopped using the service. Notice that the code calculates this by checking which rows have yes in the churn column, reflecting how many respondents reported leaving. This helps illustrate how key behavioral metrics, like churn rate, can be directly derived from survey data columns. Let us analyze marketing campaign data to see who responds to offers. We add a business-oriented comment. We download the bank marketing campaign dataset. We fetch it as a pandas data frame. We rename columns for clarity so teams understand what each one represents. We check dataset size to know how many customers and variables we have. We preview 3 records for context on age, job, and response. Running the cell now. This output shows the shape and first 3 rows of a marketing campaign survey dataset with 45,211 responses and 17 features. Notice each row represents one customer, and columns include demographics, age, job, financial info, balance, and campaign details, duration, previous contacts. This helps us understand the structure and variety of data types before analyzing customer behavior or response trends. Knowing what share of customers responded measures campaign effectiveness. We annotate to clarify our key business metric, response rate. We compute the percent of customers who said yes to the campaign offer. We display this as a manager-ready summary. Running the cell now. The output shows a 0% response rate, meaning no participants answered yes to the response question in this dataset. This highlights the importance of checking how responses are recorded and labeled, as 0 responses could indicate a data issue or no engagement. Understanding response rates helps assess survey effectiveness and guides further analysis. NPS is a standard way to track brand advocacy. It ranges 0, not likely to recommend, to 10, extremely likely. We add a business-focused comment. We use a fixed seed so results match if rerun. We create a synthetic NPS dataset with customer demographics and randomized NPS scores. We preview 3 NPS responses to check if our structure matches market research needs. Running the cell now. This output shows the first 3 rows of a synthetic NPS survey dataset, where each row represents one customer's response, including their age, region, and NPS score on a 0 to 10 scale. Notice the variation in ages and regional distribution, highlighting how demographic and geographic factors can be captured alongside customer sentiment in survey data. This helps emphasize that each row is a unique respondent's data, critical for analyzing patterns and trends in customer feedback. Brands want to know which regions have stronger advocates or dissatisfied customers. We clarify that our next step is segmentation. We group by region and compute average NPS per group for localized business insight. We clearly announce the results. We display the per region NPS for direct comparison. Running the cell now. This output shows the average Net Promoter Score, NPS, by region, summarizing customer sentiment across different geographic areas. Notice that North has the highest average NPS, indicating relatively more positive feedback, while East has the lowest. This aggregation helps us understand regional differences in customer experience, a key insight when interpreting survey data by groups. Practice: which region would you prioritize for follow-up? Companies commonly count detractors 0 to 6, passives 7 to 8, and promoters 9 to 10 to summarize brand mood. We state our intent to make market-friendly segments. We use PD cut to convert scores to business categories. We show the new column alongside existing ones for QA and next steps. Running the cell now. This output shows how individual survey responses are classified into NPS categories based on their scores, with each row representing a single customer's score and assigned type. Notice the clear segmentation of low scores, 0 to 6, as detractors and a high score, 9, as a promoter, reinforcing the importance of correctly interpreting rating scales in market research. This step is crucial for analyzing customer sentiment by grouping responses meaningfully. Visualizing churn by contract type reveals which products or offers lose more customers. We import Matplotlib for charting business metrics. We calculate the churn percentage for each contract type. We plot the churn rates as bars for clear visual impact. We set the y-axis label to clarify metric. We add a descriptive title to focus on insight. We rotate X labels for readability. We ensure plot does not overlap. We display the plot. Running the cell now. This bar chart shows the churn rate percentage for each contract type in the customer survey data. Notice how the y-axis represents the proportion of customers who said yes to churn, highlighting differences in retention across contract types. This visualization helps connect respondents' contract choices to their likelihood of leaving, a key insight in market research for targeting retention efforts. Knowing common jobs helps design persona-based campaigns. We annotate our business reason. We count how many customers work in each job group, highlighting the top 5. Running the cell now. Here, we see the 5 most common customer job categories in our survey data, with blue-collar and management leading in frequency. This output helps us understand the composition of respondents, reinforcing that each row represents one customer, and the job column captures their occupation. Noticing these counts is key to interpreting the market segment distribution before deeper analysis. Cross-tabulating lets you see if response rates differ for customers with versus without housing loans. We set up the analysis in business terms. We build a crosstab between housing status and campaign response, adding totals. We display the table so product, analytics, or marketing teams can see where to focus. Running the cell now. This crosstab shows how survey responses, 1 versus 2, are distributed across whether respondents have a housing loan, yes or no. Notice more response 1 answers come from the yes group, while response 2 counts are higher in the no group, reflecting different patterns by loan status. This helps beginners see how to compare categorical variables and understand the customer segments behind responses. Missing values are common in real surveys and can distort results if not handled. We start from the business need of reliable results. We copy our data to not alter the original. We make the first 10 churn fields blank to simulate non-response. We count how many are now missing so we can spot gaps early. Running the cell now. This output shows there are 10 missing values in the churn column after we intentionally set the first 10 rows to none. Notice how this simulates real-world survey data where some respondents might skip questions. Understanding and identifying missing data is key before analyzing customer churn behavior reliably. Practice: how would missing values change the computed churn rate? Excluding missing survey answers gives a true, fair churn rate. We clarify our business focus. We remove missing answers from the churn column. We recompute the percentage of churn only for valid responses. We print the corrected churn metric for decision makers. Running the cell now. This output shows the churn rate calculated by excluding any missing responses from the churn column. Notice that 26.52% of valid respondents reported they churned, which means over a quarter of customers stopped using the service. This example highlights that when working with survey data, it's important to handle missing answers carefully to avoid skewing metrics like churn rates. Calculating a market-facing score like NPS index lets leadership prioritize customer experience. We provide context, business needs a standardized summary. We count the total number of NPS records. We count promoters, score 9 to 10. We count detractors, score 0 to 6. We compute the industry standard index. We print the NPS index for voice of customer benchmarking. We give a recommendation if the index is negative. We suggest prioritizing conversion of passives if the NPS is modest. We encourage maintaining the strategy if advocacy is strong. Running the cell now. The output shows an NPS index of -47.60, indicating that detractors significantly outnumber promoters in this survey data. Since each row represents a customer response categorized by NPS type, this negative score signals poor customer sentiment overall. The code's intent here is to quantify this balance and guide action. A negative NPS triggers a recommendation for urgent improvements to address dissatisfaction. YouTube, want a full NPS dashboard in Python? Search YouTube for the Market Research Python dashboard. Age bands show which generations respond best to campaigns, so resources are not wasted. We explain the segmentation business need. We assign customers to age groups fit for reporting. We group by age band, then response, converting to percent to assess propensity. We display the segmentation table for easy campaign targeting. Running the cell now. This table shows the percentage breakdown of survey responses, 1 or 2, across different age groups, created by binning ages into segments. Notice that the majority in each group selected response 1, with the highest proportion in the 36 to 50 segment, highlighting how customer opinions vary by age. This demonstrates how segmenting data helps uncover trends and differences within key demographic groups, a crucial step in market research analysis. It is vital to check for and handle blank open-ended feedback, so sentiment analysis is accurate. We suggest simulating a real-world quality problem. We create a data frame with one blank feedback field. We check for feedback rows that are empty after removing spaces. We print the number of missing feedbacks to prioritize improvement. Running the cell now. This output shows that out of 5 customer feedback entries, 1 is effectively blank or missing text after stripping spaces. This highlights the importance of checking for empty responses in survey data, as blank answers can affect analysis of customer opinions and must be handled appropriately. A common pitfall is counting low NPS as good for business. This could drive wrong strategy. We add an explanatory comment. We show a logic error, counting scores 0 to 6 as promoters. We print the count to illustrate why accurate logic matters for managers. Running the cell now. Here, the code mistakenly counts customers with NPS scores of 6 or below as promoters, which is incorrect since low scores indicate detractors or passives. Notice how the high count, 323, reflects this error, emphasizing the importance of understanding the NPS scale correctly to avoid misclassifying respondents. This reinforces the lesson that knowing the meaning behind rating scales is crucial in interpreting survey data accurately. Practice: check team logic before reporting important scores. A common mistake is a misspelled column name in grouping. Always double-check field names. We add a clarifying comment. We use a try block to attempt to group data by a misspelled column. If an error occurs, we catch it and print a useful message. The printout helps prevent hours lost to simple typos. Running the cell now. This output shows a key error caused by trying to group the data on a non-existent column AG. Notice that the error highlights a common beginner mistake, misspelling column names when summarizing survey data. This reinforces the importance of careful column referencing to correctly analyze survey responses by the intended categories. Segmenting customers by contract and outcome reveals where to add retention incentives. We provide a business-first comment. We count how churn and contract type combine, giving exact numbers. We print the segmentation table for teams to take direct action. Running the cell now. This table shows customer counts grouped by contract type and whether they churned. Notice that month-to-month contracts have the highest churn, 1655 yes, while longer contracts like 2-year have much lower churn rates. This illustrates how segmenting data by key features reveals important trends in customer behavior, a core step in market research analysis. You can find high-risk groups by examining churn rates across payment methods. We set up the business use case. We cross-tab payment method against churn outcome, converting values to percentages for comparison. We display the data so payment, risk, or marketing teams can use it right away. Running the cell now. This crosstab shows the proportion of customers who churned or stayed by payment method, highlighting key differences in churn rates. Notice how electronic check users have a much higher churn rate, 45%, compared to automatic payments like credit card or bank transfer, which have lower churn around 15 to 17%. This helps illustrate how categorical columns like payment method can reveal important customer behavior patterns in survey data. YouTube, for advanced analytics tips, check a market research analytics Python on YouTube. Trend analysis shows if recent customer cohorts are more or less engaged than previous ones. We start with a business explanation. We set the seed for reproducibility. We define a date range for synthetic month-by-month cohorts. We create the data with random active user counts. We annotate the business analysis trend. We import matplotlib for plotting. We plot cohort month against active users to visualize changes. We set an informative title. We label the x-axis as sign-up month. We label the y-axis as active users. We activate grid for easier reading. We fix chart layout. We display the trend plot. Running the cell now. This line chart shows the trend in active users for different customer cohorts by their sign-up month. Each point represents the number of active users in a specific month, helping us see fluctuations or growth over time. This visualization reinforces how cohort data captures behavior linked to when customers joined, which is key in tracking retention or engagement trends. Let us finish by solving an applied business question: what predicts churn in a vulnerable customer segment? We clarify the end-to-end scope. We filter for rows where the customer is flagged as a senior citizen. We create a new variable putting monthly charges into 3 groups for actionable targeting. We group by monthly charges and calculate churn outcome as %. We display who is most at risk, allowing retention offers or outreach. Running the cell now. This output shows the churn rates broken down by monthly charges among senior citizens, categorized into low, medium, and high spending groups. Notice that medium spenders have the highest churn rate at about 46%, indicating they are more likely to leave compared to low or high spenders. This highlights how segmenting by key variables can reveal specific customer groups driving churn, which is critical in market research for targeted retention strategies. Practice: what business action would you recommend based on these results?